Number one, we have probabilities for the standard normal distribution. Anytime we see the letter Z, we're dealing with the standard normal distribution. The standard normal distribution is just a normal distribution with mean, also denoted by mu, equal to 0, and standard deviation, denoted by sigma, equal to 1. The nice thing is, anytime we see probabilities related to the standard normal distribution, so probabilities with the letter Z, we can calculate these probabilities pretty easily using what we call our normal table, which will look like this. So the important thing to understand about the normal table is that the normal table gives you the area for any value of Z. It gives you the area to the left of it. Or in other words, so let's say that this value is -1. The normal table will always give you the probability that Z is less than that value, that Z is less than -1. So for example, this value right here, that tells us that the probability that Z is less than or equal to, or strictly less than, -3.40 is equal to 0.0003. That's how we read our normal table. So the first part of this question wants the probability that Z is greater than -1.86. So this is equal, if we want to draw a picture, this is equivalent to asking, what's the area to the right of -1.86? Now remember that our table only gives us the area to the left, so we have to add an extra step to get this area to the right. One way we can think about it is using one of our probability rules, which says that the probability of A is just equal to 1 minus the probability of not A, or the opposite of A. So therefore, the probability that Z is greater than -1.86 is equal to 1 minus the probability of the opposite. The opposite of being greater than is being less than or equal to. So the probability that Z is greater than -1.86 is 1 minus the probability that Z is less than or equal to -1.86. Another way we can think about it is that the area, the total area under the normal curve, is equal to 1. So if I take the area to the left plus the area to the right of -1.86, that'll equal 1. So the area to the right of -1.86 is just 1 minus the area to the left. All right, so now we can use our normal table to find this probability. So to find the area to the left of -1.86, I go to the row corresponding to -1.8. I want -1.86, so I go to this column, and therefore the probability that Z is less than or equal to -1.86 is 0.0314. So then the probability that Z is greater than -1.86, if I plug this into my calculator, is 0.9686. Next, I want the probability that Z is between -0.68 and 1.94. this is best explained with the picture. So I'll draw my normal curve again. So I want the probability that z is between negative 0.68 and positive 1.94. So that's precisely the area between these two numbers. So I'll highlight it here. So if I want the area just in the middle, well, I can notice that, well, the table will give me the area to the left all the way to the left of 1.94. In other words, the table will give me this area. The table will also give me the area to the left of negative 0.68. I just want this area right here. So the area between these two is just equal to the area to the left of 1.94 minus the area that I don't want, this part here, which is the area to the left of negative 0.68. I can find these two values in my table. So let's first find the probability that z is less than or equal to 1.94. So I'll go down to my table. I want to make sure I'm dealing with the positive numbers. 1.9, so I'll look for 1.9, which is this row right here. Then I want 1.94, so I'll go down here. So the probability, the area to the left of 1.94 is 0.9738. I'll write that down. And the area to the, the area to the left of negative 0.68, I'll go find negative 0.6. And where's my 8 column? It's right here. So the area to the left of negative 0.68 is 0.2483. I can plug this into my calculator to find that the area between negative 0.68 and 1.94 is just 0.7255. Let's go to part C. For part C, I want the probability that z is between 0 and 3.85. I'll draw us another picture. So I'll mark off 0 and 3.85, which will be somewhere over here. And I want the area between these two numbers, which I'll shade in here in blue. Remember, the table gives us the probability to the left of each number. So if I look for 3.85 on the table, it'll give me the area all the way to the left of 3.85. Well, I don't want all of that area, I just want the shaded area. So in particular, I want the area to the left of 3.85 minus this area I don't want, which is the area to the left of 0. So I take the area I want to the left of 3.85, subtract out what I don't want, the unshaded area, which is the area to the left of 0. I'll find these probabilities in my table, 3.85 and 0. I want to go to my positive numbers. So the area to the left of 3.85. Well, on my table, my z-values only go up to 3.4. 3.85 is quite literally off the charts. So how do I find the area to the left of 3.85? Well, in this case, for areas for z-values that are either too small or too large for our table, we can estimate them. Particularly, we can notice that as our z-values get larger, in other words, as we go down the table, so do the areas. In fact, the areas get closer and closer to 1 as my z-values get larger. So therefore, for any z-value greater than 3.4, we can simply approximate it with the area to the left with 1. So as you can see, we have 0.9997, 0.9998, and so on. So we're getting closer and closer to 1. So I can approximate the area to the left of 3.85 with 1. Next, I want the area to the left of 0. So I find 0 on my table, 0.00. So the area to the left is 0.5. I approximated 1 here, so I'm just going to add an approximately equal sign here. So therefore, the area in between these two numbers is approximately 0.5. Let's go to part D. Part D, we want the area between negative 4.34 and 0. I'll draw myself a picture. So I'll put 0 in the middle because remember that's the mean of the standard normal distribution, so it'll always be in the middle. Negative 4.34 is all the way out here to the left. I'll shade in the region that I want. Okay, so I know that the table will give me the area all the way to the left of 0. I want to subtract out the area that I don't want, which is the area to the left of negative 4.34, that unshaded region there. So this is equal to the probability that z is less than or equal to 0 minus the probability that z is less than or equal to negative 4.34. I can remember from the last time I looked at the table, the probability or the area to the left of 0 was 0.5. Now we just have to find the area to the left of negative 4.34. So I go down to my chart to the negative side. Well, similar issue as last time. Negative 4.34 is off the charts. My z-table only goes as small as negative 3.4. Negative 4.34 is smaller than that. So I have to approximate the area to the left. Well, notice as I get more and more negative, the areas get smaller and smaller. In fact, the areas get closer and closer to 0.0000, aka just 0. So I can approximate the area to the left of any z-value smaller than negative 3.4 with 0. Since I'm approximating, I'll put my approximately equal sign here. 0.5 minus 0 is just 0.5. So the area in between negative 4.34 and 0 is about 1/2 or 0.5. Part E, we want the probability that z is greater than 4.82. So, greater than 4.82, that means I want the area to the right of 4.82. Remember that the table only gives us the area to the left. So this is equal to 1 minus the opposite of being greater than 4.82. So this is 1 minus the probability that z is less than or equal to 4.82. So I go down to my table. Remember, my z table only goes to z values as large as 3.4. 4.82 is larger than that, so I'll approximate the area to the left with 1. So the probability that z is greater than 4.82 is about 1 minus 1. So the area to the right is 0, approximately 0. Last one, part F. We want the probability that z is less than negative 6.12. So for any continuous distribution, like the normal distribution, we can treat less than signs and less than or equal to signs the same. We can treat greater than or equal to signs the same. So the probability that z is less than negative 6.12, I want the area to the left. Negative 6.12 is even smaller than my smallest value on the z table, so I can approximate the area to the left with 0. So the area to the left of negative 6.12 is approximately 0.